Hello, my dear children. Today we are going to discuss about the sums in exercise 1.2 in the chapter sets. Okay. In the previous class, we have discussed the definitions. What is null set? Okay, my dear children. What is equal sets? Now, with the help of the points, we solve the sums in exercise 1.2. See question number 1. Which of the following examples of the null set? Which of the following collections, which of the following sets are null set? Okay, my dear children. See the first question. Set of odd natural numbers divisible by 2. We have to write the set of all odd natural numbers divisible by 2. Is it a null set or not? See, there is no odd natural number divisible by 2. Odd natural number means it is not divisible by 2. Only even numbers are divisible by 2. So, there will be no element in this set. We can't write any odd natural number which is divisible by 2. We can't find it. That is why there is no element in the set. Hence, it is said to be null set. Understood, my dear children? If there is no element in a set, what is the set said to be? A null set or an empty set or a void set. Okay, my dear children? Right. Now, come to the question number 2. Set of even prime numbers. We have to check whether this set is a null set or not. Come to the solution. There is only one even prime number, which is 2. 2 is a even number as well as it is a prime number. That is, there is an element in the set. In this set of numbers, 2 is a one element. So it is not a null set. Then what is this set said to be? A singleton set, because one and only one element is there. So it is said to be a singleton set, not a null set. Understood, my dear children? Right. Now come to the next example. Set of all x such that x is a natural number, x less than 5 and x greater than 7. Now we have to verify that is this set a null set or not. Come to the solution. There is no natural number which is less than 5 and greater than 7. We can't find any natural number which is less than 5 as well as it is greater than 7. That is, there is no element in the set. There is no element in the set. So, the set is said to be a null set. Understood, my dear children? Right. Now, come to the question number 2. This question is given on the definition of, based on the definition of finite set or infinite set. Here some sets are given. We have to identify which set is a finite set and which set is an infinite set. So we have to recall the definitions of finite set and infinite set to write the answers. Okay, my dear children? Right. Now, come to the question number 1. The set of months of a year. This is a given set. Is it a finite set? Yes. Come to the solution. The set of months of a year is a finite set because there are finite or definite number of elements in the set. There are only 12 months. A finite number of elements are there in the set. That is why this set is called a finite set. Understood, my dear children? Right. Now, come to the next set. Set 1, 2, 3, and so on. if you observe this set, there are infinitely many elements are there. After three dots are there. Three dots are there means there are infinitely many elements are there after 3. So come to this solution. The given set is an infinite set because there are infinite number of elements in the set. Understood, my dear children? Right. Now come to the next question. Set 1, 2, 3, and so on 99, 100. Here last elements are also given clearly, right from the beginning to last element. In the between only few elements are not written. Okay, my dear children. Now come to the solution part. Is it a finite set? Yes, it is a finite set because it contains 100 elements in the set. Okay, my dear children, we can't write all 100 elements. That is why we keep here 3 dots. It doesn't mean there are infinitely many elements between the numbers. Okay, my dear children, at the end, if we keep 3 dots, it means it is an infinite set, not in the between the numbers. If we keep 3 dots between numbers like this, it is not said to be infinite set. It is a finite set. Understood, my dear children? Right. Now come to the question number 4. This question was given based on based on the definition of equal sets. Okay, my dear children, you have to recall the definition of equal sets. Now come to the question. A is equal to set A, comma B, comma C, comma D, and B is equal to set D, comma C, comma B, comma A. Now we have to check whether these two sets are equal or not. See, come to the solution part here. The sets A and B have exactly the same elements. Therefore, A is equal to B. You know that if two sets are having the exactly the same elements, order of elements, that doesn't matter. Order of elements in the set, we can write the elements in any order. Okay, my children. So here A and B are equal sets. Understood, my dear children? Right. Now come to the next question. A is equal to set 4, 8, 12, 16, and B is equal to set 8, 4, 16, 18. Two sets A and B are given. Now we have to check whether these two sets are equal or not. So this question is also based on the definition of equal sets. So here come to the solution part. Here 12 is an element of set A. See here 12 is an element in the set A, but it is not an element of set B. Understood, my dear children? Similarly, 18, here 18 is an element of set B, but it is not an element of set A. This element is not in the set A. Understood, my dear children? That is, sets A and B are not having exactly the same elements. Then what do you say? They are not equal. So we wrote here A is not equal to B. Understood, my dear children? Right. Now come to the next question. A is equal to set 2, 4, 6, 8, 10. This is a set A. And set B is equal to set of all x such that x is positive even integer and x is less than or equal to 10. Okay, my dear children. Now we have to check whether these two sets are equal or not. So first of all, we have to write set B in the roster form. Without writing a set in the roster form, we can't compare the two sets. That is why here we wrote set B in the roster form. What are the elements in the set B? 2, 4, 6, 8, 10. Positive even integers less than or equal to 10 means these are the elements in the set B. Now compare the elements in the set A and the set B. Are the both sets have the exactly the same elements? Yes, here sets A and B have exactly the same elements. Therefore, we can say that the two sets are equal. So, we wrote here A is equal to B. Understood, my dear children? Right.